A very good morning to all the students. I hope every one of you is fine and in your best health. So, before starting our today's lecture, I would like all of you, to read these instructions, which are the appropriate behavior to deal with this COVID-19. So, we have to wear mask. We should follow physical distancing. We should maintain health and hygiene, hand and hygiene. Now, we know that we have been doing all these things since quite a long time, but as time is passing by, we are forgetting all these things. So we should not forget to wear our mask properly. We should stay at least 6 feet away from others. We should wash our hands frequently, always with soap and water, and at least for 20 seconds. We should remember not to touch our face, and we should not share our food or drinks with the others. So by keeping all these things in our mind, we can be safe, and our family will also be safe, and we can deal with all these problems. So after this, let's start up today's lecture, which is about mole concept, which start with the topic of today, which is mole concept. And this is from chapter number 3. So we have been doing this chapter since quite a few weeks, and so far we have covered each and everything from the chapter, and today would be probably our last lecture on this chapter. In the continuation with the topic, so we'll be further studying about mole concept. So mole is the counting unit, so which has been used to calculate mass of all such unit or particles which are very small and are in bulk. And mole is a link between the mass of atoms and the number of atoms. Okay, so mass of the atoms and number of atoms, so there is a link between them. So whenever we need to calculate the number of atoms, or we need to find out the mass of the atom, we use this mole concept, because the atoms or ions or molecules are so tiny that we can't count them one by one. So instead of doing that, we just find the mass of that thing, and by getting the mass of that thing, we come to know the number of atoms, because that is fixed. Fixed because it is having a fixed value, which is called as Avogadro's number, which is a constant number, which is 6.022 into 10 to the power 23. So to solve this mole concept, mole numericals, we should know formulas, and along with that we should also know the values. Okay, so here are some values which already we have done in our previous lecture. So we'll be revising them again, so that we can do a few more numericals today. So just revision again. Now, number of atoms are represented by n. So number of atoms, or it can be number of ions or number of particles, so they are all represented by capital N. Then comes number of moles. So number of moles, actually mole is defined, the unit of mole is mol, mole, but to represent a number of moles in any formula or any question or any numerical, we use this small n. Then molar mass is represented by capital M, given mass by small m. Avogadro's number, which is constant, which is 6.022 into 10 to the power 23. Okay, now here comes the formula. Now if we have to find out number of moles in any question, it's been given like find out the number of moles, and we will do use this formula, which is n equals to small m upon capital M, which means that small m is given mass and capital M is molar mass. And then the other formula which we are having is small n equals to capital N upon N naught. So sometimes the mass are not given, only the number of atoms are given. So in that case, we have to use this formula, where capital N is the number of atoms or number of particles, and N naught is the Avogadro's number. So since this and this are quite similar, so small m, n equals to m upon m, and here small n equals to n upon n naught. So by this we can also relate that small m upon capital M equals to n upon n naught. Okay, so these are the formulas. So now with the help of these formulas, we'll be doing some more questions. Okay, now here comes a question from the NCRT book. Firstly, we'll be doing this question, and then we'll solve the textbook questions as well. Now here it's calculate the number of particles in each of the following. Now here we have to find out the number of particles. Okay, so now when the question comes, find out the number of particles, that means the formula we'll be using is n equals to n upon n naught. Okay, so the question is Okay, so 46 grams of any atom. So because grams are given, so the given mass is given as 46 grams. Okay, and we have to calculate that number of particles, so we have to calculate n. Okay, we don't know n, so only the things which have been given is 48. Small m is given, and we know the formula. The formula is n equals to either m upon m, and the other formula is n equals to n upon n naught. Okay, so with this we can get a new formula, which is m equals to n upon n naught, which will, and we have to find out this. Okay, so this will be n equals to m upon capital M into n naught, because this will come here, so this will go here, and this will come here. Okay, so this is the formula which we have got. Now we have to find out n. So we have this value, this is 46, and molar mass is fixed because this is any atom, and we should be knowing what is the molar mass of Na. Okay, that is 23 molecular mass. Na is 23. Okay, then it will be multiplied by the n naught. Now n naught is what? Avogadro's number, which is constant value, 6.022 into 10 to the power 23. This is very simple. Okay, so the answer will be, you have to calculate this. So answer is 12.044 into 10 to the power 23. Okay, so this is the number of particles. Now next question is, okay, 8 grams of O2 molecules. Now here was Na, now here is O2 molecules. Now M, so M is given, so M in this M, small m is 8 grams. Okay, so small m is 8 grams, and so molar mass will be oxygen, its molecule. Okay, don't forget it's oxygen molecule. So 1 is 16 and 2 will be 2, it will be 32. Okay, so capital M is 32, and again we have to find out n. So n equals to m upon capital M into n naught, and by placing the value, it will be 8 upon 32 into 6.022 into 10 to the power 23. Okay, so the answer will be, we have to calculate this number. So by cutting this, we will be getting 1.5055 into 10 to the power 23. This is the answer. Okay, now there is one more question in this. Let's find out the what is 0.1 mole of carbon atoms. Okay, so now they have given mole value. Okay, they have not given us in grams, so they have given mole, and mole means small n. So they have given small n, and along with that carbon atoms. So to solve this, how will we be doing this? Okay, now so third, so in this, the number of particles. Okay, so we have to calculate the number of particles. So for this, n equals to small n into n naught, because now we can write this small m upon capital M. So small m upon capital M into n naught, and we know that n equals to small m upon capital M. So instead of using this, we can use this directly. Okay, so we know that this, we don't have, why do we need all these values when we have already this? So we'll be using n equals to now small n into n naught, and the value of small n is already given, which is 0.1 into 6.022 into 10 to the power 23. So it will be 6.022 into 10 to the power 22. So the n is this. These are very simple questions. Okay, so I think these are clear to you because they are also solved in your NCRT book. Now we'll be doing some more questions which are from the NCRT book. So this question is, if 1 mole of carbon atoms weighs 12 grams, if 1 mole of carbon atoms weigh 12 grams, what is the mass in grams of 1 atoms of carbon? That means that 1 mole of carbon atoms has weight of 12 grams. So what is the mass of 1 atom of carbon? Okay, so that's very simple. We'll be doing this from textbook. So simple, we can define that 1 mole 1 mole has actually 1 mole of carbon atom means or have 6.022 into 10 to the power 23 carbon atom actually. Okay, so in this case obviously 1 mole of carbon weighs 12 grams, or we can see that 6.022 into 10 to the power 23 carbon atoms weighs 12 grams. Okay, so we can also write 6.022 into 10 to the power 23 atoms of carbon have equals to mass equals to 12 grams. So 1 atom of carbon have mass equals to 12 upon 6.022 into 10 to the power 23. Okay, so we'll be dividing this, so it will be okay, 6 on the 6, it will be 1.99 into 10 to the power 23 and will be minus, because it will become come up, so it will be in minus value. So that means 1 atom of carbon have mass of this much. Okay, 1.9 into 10 to the power minus 23 grams. Okay, so this is done. Now next question is, which has more number of atoms, 100 grams of sodium or 100 grams of iron? Okay, so this is a very simple question. This always we know that they are asking that which has more number of atoms, 100 grams of sodium or 100 grams of iron. So we have to find out the number of atoms, or we can also find out number of moles, because number of moles is very simple. We have been given the weight, that is small m, and capital M we already know, because sodium is given 23 and for iron it's given 56. So we can easily find out n. So n n here is actually the moles of sodium. Okay, so n is small m upon capital M. So we can do like n equals to small m is been given, and small m is 100 grams and m is 23. Okay, so it will be 100 upon 23, so it will be 4.3. okay, for sodium. And for moles of iron, okay, so here n is, again weight is 100 and it's 56, it will be 1.78. okay, so we can easily see that the number of moles with 43, and it's here it's 1.78. obviously it's lesser, so because in the mole it is a relationship between the mass of the atom and the number of atoms. So since the mass of the atom is less here, so obviously the number of atoms will also be less here. Or we can also do this way, like it's n equals to n upon n naught, and here for this one we are having 4.3 equals to n. Now n we have to find out, and we have n naught. So n equals to 4.3 n naught. So n naught is Avogadro's number. It will be into 6.0, and that's 6.0 double to into 23. So this will be more, and if we'll do for the iron, it will be lesser. It will be 1.78 n naught. So obviously, this is smaller and this is bigger. So the sodium, so answer will be sodium. Sodium will be having more atoms than 100 grams of iron. Okay, so answer is this. So these two questions are also done. So I think now these are clear to you people. So you can be doing this questions as of your homework. So if you have any problem, I will help you to solve these questions. For now, please do all these questions. Okay, for as in your homework, and this chapter is completed now. We'll be doing these questions. If you have problem, I'll be taking another lecture video on this, on how to solve these questions and many more numericals you can do. Okay, so till then, please take care and do your work and study hard. Okay, thank you.